Hey guys, I'm just continuing straight on from the previous video. So now up to the final part, finding the x centroid, by dash, and iy dash. So I've just redrawn our problem with the reference and the centroidal axis in. Our xc, so our distance to our centroid will be around that distance there. We're going to call that xc. We know that xc equals by on a. We found by to be 2a squared on 3. The area, so we're going to do the reciprocal of the area, it's the same as dividing, 1 on AH. Simplifying this, we'll get 2/3 A. So that is XC, the distance to the centroid. The next thing we're going to have to find is BY dash. So BY dash, every time we have a Y dash for the first moment of area, it's always just 0, so that's very simple. And the last thing we need to find is IY dash, which is the integral of x dash squared dA over the area A. Now what we're going to have to do is we're going to have to develop a formula for x dash in terms of x. We have this function here, which is a function of x, hx on A, and we have this function here, function of x. I'm going to call that function x1, function x2, which is minus hx on A. So we've just seen that in previous videos. We're going to have to come up with a formula to relate our reference axes to our centroidal axes, and it's going to look like this. X equals xc plus x dash, where x dash ranges between 1/3 A and minus 2/3 A. So the way I found that was that our distance to our centroid is 2/3 A, so from there to there. So if we were going this direction and this direction, to get to the end of our point there, we would be going minus 2 on 3A that way. To get to the end there, because we know this distance is A, it would be A minus 2 and 3, so we'd be going 1/3 A there. So that encloses the space in terms of x dash. In terms of A, we know it's from, in terms of x, it's from 0 to A. From 0 to A in terms of this reference axis. So let's show that this makes sense. For example, when we have x dash is minus 2 on A, 2A on 3, we know xc is 2A on 3, so that would give us 0, which is that value there, so you can see they correspond. When x dash is 1/3 on A, this would be 1/3 on A plus xc, which is 2/3 on A. If you added those together, you would get A. So you can see that these points correspond in terms of that formula there. So what we're going to do now is we're going to sub in for x into our functions, so we get them in terms of x dash. So it's going to look like this. We have function 1 of x equaling hx on A, subbing in for x, which is xc plus x dash. We know xc is 2 on 3A plus x dash. And if we simplified this, just expanding it out, we would have 2 on 3h plus hx dash on A. So we have now a function 1 in terms of x dash, because we have x dash here. Same thing for function 2 of x, it equaled minus hx on A, subbing in for x, xc plus x dash. Subbing in for xc, we know it is 2 on 3A plus x dash. And then expanding this out, we're going to get a function 2 of x dash, which would be minus 2h on 3 minus hx dash on A. Okay, so there are our two new functions in terms of x dash. So back to our iy dash integral is this thing here. So it's going to be the integral from, now the constant in this case, normally we have c1, c2, that's going to be minus 2a on 3, 1a on 3, so minus 2a on 3, 1/3 A, between our new functions, so this function here, minus 2h on 3 minus hx dash on A, 2h on 3 plus hx dash on A, x dash squared, and dA, which would be dy dx, just being consistent that this is, although it's in terms of x dash, we're doing it for y, and this x is for the constants there. So that just takes us back to our first video where we've been using this format the entire time. So that is iy dash. It's the exact same, sorry, it's the expanded version of this thing here. That thing there. So it's quite ugly, but we're just gonna have to do it. So if we were to solve this, we're gonna put, I'm just gonna call it dot dot just to save a bit of time, but it's that value and that value, and dx. So that's our outer integral. For our inner integral, we've got x dash squared dy. So we're gonna be integrating for dy. Think of x dash squared as a constant times by y outside of 2h on 3 plus hx dash on a minus 2h on 3 minus hx dash on a. So because we integrated for y, these are going to substitute in for y. So it's going to be that integral on the outside. So it's going to be x dash is essentially a constant, x dash squared, outside of subbing in for y, 2h on 3 plus hx dash on a minus 2h on 3 minus hx dash on a. Now simplifying this, we would get the integral between x dash squared outside of 4 on 3h plus 2h x dash on a dx. So going a step further, I'm going to take out an h and expand the x dash squared in. H is common, it's just a constant. X dash squared I'm going to put in. So we're going to have the integral like this. H is coming out the front. We're going to have 4 on 3 x dash squared. Let me try to put this in the same screen. Okay. Plus 2 on a x dash cubed dx. So that's what we're up to. Now we're going to integrate this with respect to x. So h is out the front. We would get 4 outside of x dash cubed on 3 plus 2 on a x dash to the power of 4. Putting a 4 on the bottom would be 4a between our values, which was 1, so plus a third a minus 2/3 a. Okay guys, I'm going to let you do the actual substitution. It's not that hard, just you're going to sub in for a third a where x dash is and minus 2/3 a where x dash is there. If you solved all this, you would find that ix dash is ha cubed on 18. So there you go guys, that's pretty much summarizes this entire process. So we've looked at strips and squares. And yeah guys, I hope that summarizes it and helps you out. We'll see you in the next video.